because it's delta T over 2, that's the most intense time of the runoff event. Yeah, so that's how you associate that with your delta T over 2. Okay, so with that, I'm just going to move on because we have limited time. So now the next question you're supposed to ask me is, great, you have a pretty graph. What do you do with it, right? So the next thing is we need to figure out how we can extract the volume based on the hydrograph you have. Because now you have the pre-development, you have the post-development hydrograph, right? So you can now technically copy these coordinates of this hydrograph out and do the analysis just like what we did in class to end up with a volume of your detention. And the concept is if you have a pre-development hydrograph, and if you have a post and pre-hydrograph, anything in between is going to be the volume that you want to detain. There's the excess flow you cause, right? So in this case, I'm going to be really honest with you. I don't know what SSA is doing in that step, but I can show you how to get that through SSA, how to get your volume through SSA. My warning is this is black magic. I try to find where that how they got it. I cannot find the source. So yeah, if you ask me if I believe this, no, I don't believe what SSA is doing when it comes to getting the detention basin volume. Okay, but I'm going to show you anyways because your boss may like it. The fact that I would like it doesn't mean that your boss would like it. So I'm going to show you anyways how to do this. Okay. So let's say this is my pre-development peak. You click on the pre-development peak. Oh, you're going to come here and click on that pre-development peak. It's going to give you a coordinate. And what does that coordinate tell you? The coordinate of the peak, right? So the coordinate of the peak has two things. One is the time issue. The other one is the flow issue. That's right. So what you want to do is come take a look at the QP, right? Is what? 2. Okay. Okay. So, doesn't allow me to do that. There's a way for to input the detention storage. I don't know why
You have to change thresholds first.
No, you don't need to change the thresholds. I think I was wrong. I ran these at the same time. So if you ran it at a different time, you can save your pre-development graph, right? And then you can generate the post-development graph just like what we did. Re-import in the pre-development graph. Now, if you do that, I believe that option is going to be open. Okay? So what you do next? Is you put in the maximum flow that you want to allow the detention basin to release. And in this case, our maximum flow is going to be the pre-development flow because we don't want to exceed that, right? That's the maximum that we have described. So you can put it in there, and once you put it in there, it automatically spits out the volume that you need somewhere over here. Yeah, detention storage. It automatically spits out that value once you put in your maximum outflow. Now, did we ever specify what outflow structure we have? Exactly. How the hell did they know? What the detention storage ought to be? In this mean, right? So that's why I say I don't trust it, but it doesn't mean that your boss, won't like it. Your boss will prefer that.
So we have to put development Q.
Yeah, let me try something real quick. Let's say I have this, then I import in this. So I'm going to trick the program and say if I can say both, right? And then import both. Time series. Oh yeah, now it's open. Okay, give me 1 second. I think they are on something here. What was the number?
Like 234.05.
He's definitely doing something funky. Okay, so first of all, I haven't specified my output structure, right? As far as what the elevations is, all this, I only specify the maximum allowable flow rate. Right? The way that this is done is it automatically gives you a volume. Now, in the past, that volume doesn't really depend on even the FH as a WA simple formulation doesn't depend on your release outflow at all. But for some reason, it's able to know all these things, right? And this is my personal experience as well. When I use this, there was one project that I did. I use this, right? I got a very small volume versus if I use a different method to do it. And they're actually small. It's like 10 order, 1 order of magnitude smaller. So 60,000, compared to 10,000, right? Or 6,000 compared to 60,000. So that's a huge difference. It's easier to fix issue by shrinking than expanding. Okay? So your cat work is easier to shrink the volume simply by deleting contours rather than to expand the contours. Okay? Now, with that said, I don't know what's happening here. Okay, I'm just going to rerun this. Now it doesn't even allow me to view my results. It's supposed to be. Somehow it doesn't recognize the junction as a node. Okay, so I should be okay. Okay. Now it blanked out that, so it doesn't like my grade. Okay, but that's okay. You get the picture. If you want to know how to do that, a few semesters ago I found a video, a very lengthy video, but then I can tell you between what time that happens so that you can go back and take a look at how they actually move their volume. Okay? So with that, now that you know how to use this to at least generate the hierograph of your pre-development and post-development for the different events, now you can actually get started on your project phase 2. Okay? So That's not the end of this because I haven't shown you how to do your detention, specify your detention basin. I haven't tell you how to specify your outer structure, right? So that will be the next step. So now you have a hydrograph and you know what the volume is required. Now you can go in there and tell the program the detention basin that you actually carve out in, on your AutoCAD drawing to detain the water. So the way to do that, I'm just going to go to this first. Okay. The way to do that is so this is pre, this is post, right? So the way to do that is you add something called a storage node. The detention basin is basically a storage node, right? So you add a storage node by clicking on this one button, or you can click on this button here over. It shows a whatever that is, a tank. It's like a cup, okay? It's storage, okay? So you can just click on over here and say that this is now my storage node. This is my detention basin. Okay? So you click on here and you can specify what goes in your detention basin and where you're going to put the water out from your detention basin. So we are going to go through this one at a time. Okay? First things first. You have to have an inward elevation for your detention basin. So even when you draw it on AutoCAD, you have to have a floor, the elevation for the bottom of your detention basin, and it has to have some elevation at the top of your detention basin. Okay? Now, it's not clear right now why you need that, but when we put when we go on to the next thing, you will realize that that's quite important. Okay? So inward, let's say my inward of my detention basin is 10. Okay? And then my maximum elevation, okay? Not that. Elevation, that's the difference there. So it's going to be, let's say, 16. So my that, therefore, is 6. Okay? Can you pick it up? Okay. Once you specify the elevation, okay, what you physically did is that you told the program that your detention basin is at a certain elevation. So now you have to check your downstream and upstream. Okay. The fact that you are putting something into your detention basin needs to come from a higher elevation. The fact that you're releasing a detention basin to somewhere else needs to have a lower elevation. So now your program knows what this base elevation is for your detention basin. So when you put in the other information, containing what goes in and what comes out, okay, that's going to be important. And that's part of the routing mechanism.
That's federal.
And yes, you asked about the routing, kinematic routing.
Yeah, but that's
part of
federal.
it. Huh?
That's federal.
Yeah. That's why I called his name. Pedro.
I didn't ask, was it right to ask you?
I asked.
You asked. I'm so sorry. Okay.
That's not a euro.
So let's let's figure out the other things. So your detention basin can start by having an empty detention. Yeah, so it's dry. So if it's dry, then you specify what the initial water surface elevation, not depth, elevation. You all know what the difference is, yeah? Just two? Huh? Water surface elevation means the elevation is referring to the mean sea level. It's not any, right? It's not just any value. So what that means is that now, since I have already fixed my inward elevation to 10, my minimum water surface elevation, even if it's dry, is 10, right? 10 means you don't have anything in there. So I'm going to put 10. Okay? The ponded area, sometimes when you design a detention basin, you can put a ponded area. Yeah? So I'm not going to include that here, unless you want to handle the water quality. You can
water source elevation different from the indoor elevation? If you had a pond area? Or when would the water source elevation be different from the indoor elevation?
What do you mean? When would this be different?
When would that be different from just the minimum level?
This is your initial. Let's say if my detention basin is not a dry detention, just like what you have in front of the civil building, you always see water, right? In that. So your water elevation is not the minimum water, it's not the inlet elevation. It has to start somewhere.
Okay.
Yeah. I did a project on a sort of like a recreation pond thing where you put water in there, but you also do create a park around it, right? So that's when this is useful. Okay, let's move on. I'm getting into rabbit hole. Okay, so just assume ponded area is 0 for this purpose, and then what I want to do next is I want to tell the program what my detention basin looks like. So we have a detention basin, but the program doesn't know what shape your detention basin is, how deep your detention. It knows how deep, but then it doesn't know what shape and how large the area is of every layer. Yeah? So now's the time where we specify this into your SSA. Okay, so for this, I want to do a storage curve, something called a storage curve. Okay, so remember how I taught you guys to calculate the volume inside of the detention by using the area? It's doing the same thing. Okay? So the storage curve basically tells the program at what level it has what storage. Okay? So I can do that. Okay. And let's see what I have here. That thing should appear. Did I?
Yeah, like where it says type storage curve and storage curve.
Okay.
Right there.
Oh yeah, that tree button. Yeah. Okay, you're correct. So now you hit on the tree. I thought the tree button was going to be inside here. Okay, so you hit on the tree button. Now you have the option to actually put in your characteristics of your detention basin. So again, you need to hit that because it's the first time you have a detention basin. So you hit that, and then it's going to ask you what type of detention you have. So there are different types of detention basin that is valuable. You have underground detention, you have pipe as your detention, perforated pipe as your detention, you have storage detention. Okay, so the one that we are going to do is most likely going to be a well. Yeah, don't worry about those. It's irrelevant to you if you're not doing underground detention. Okay? So you want to come over here and you want to choose between the depth versus area or the depth versus volume. In any case, right, the depth versus area or the depth versus volume, you are going to have this information after you grade your detention basin, which is why it's important for you. Once you get the volume that you need, you start grading because you are going to be pulling up this area versus elevation, or area versus depth curve and information and put it in to your SSA. Okay, so let's say hypothetically I already graded my detention and I do have the contours that's available. Okay, so I can now put in the depth versus area. So depth starts from 0. Elevation, unless you're at mean sea level, right, you are going to have a certain amount of elevation regardless. Are we on the same page? So this is why I keep emphasizing the difference between elevation and depth, because I guarantee you, one of you is going to come tell me, oh, you teach shit to me because this is right. I guarantee you, one of you are going to have that feeling because I noticed that this is one of the most common thing that students make that they don't even realize, okay? Because they cannot differentiate between a depth and an elevation. So please make note, okay, of when you need to use what. Huh? So my depth, I can start from 0 depth, and then let's say if I have a detention basin that looks something like this. Hypothetically, you can have any shape detention basin, but this is just an example. So at depth equals 0, it doesn't mean that my area is going to be 0, because you start with an area somehow, right? A point. You start with an area. So you need to pull this area and say that, right, at depth 0, my area may be, I don't know, how about 150 square feet. Okay? So once you're done, you put the next depth. Okay? It doesn't need to be increment of 1. It can be increment of 0.5, or whatever. Okay? So you go to the next one. So you do the same thing. Since you already have the contour, you are going to, as we imagine this area. So looks like this area is going to be bigger than that area, right? So you can put a different area, let's say 400. Okay? And then at depth 2, you're going to have an increase, let's say double that, 800. Okay? And then at depth 3, you have 1500. And how deep was our detention basin, by the way? 6, right? Because your inward is 10 and your maximum is 6. So I can only go up to 6 for my curve. Okay? So 4 up, like that. 4, and then I'm going to specify 2600. Now you don't need to copy my number because I'm just making things up over here. You pull this information from your AutoCAD. Okay? And 5.
So the depth would be just from the bottom. You're measuring from the bottom, so from up 1 foot from the bottom each time.
Not necessarily 1 foot. You can do 0.5.
Or you're moving upwards.
Yes.
Elevation.
As long as you move upwards, it will know exactly what to do. Okay. Then finally, I have 6 and say 10,000. Okay. Typically, your detention basin the size gets larger as you go higher. Right? If you have smaller, that means you have a waist instead of detention basin. Okay. So with that, it knows exactly with the depth versus area. Remember how I taught you guys how to calculate the volume? It's doing the same thing. It's outputting the volume for you between each consecutive layers. But this volume here is actually a cumulative volume, so the volume is always going to be increasing until you get the maximum volume that you have. So another way to check if you input this correctly is you can check the volume inside of your detention basin by making an annual calculation versus what comes out at the very end. Okay. So with that, I'm going to say this is okay. I'm going to accept this profile. And now you have storage 1 over here. And that is going to be name for your detention basin. The name is storage 1 for your detention basin. Okay. So the question becomes, how do I actually pipe things into my detention basin, right? Now, this is when you need to create a connection, a link. Okay? So there are many types of connection. You can have pipe, right? Pipe system to go into your detention. You can have open channel flow that goes into your detention or whatever. Okay? So let's say hypothetically, I'm going to have just to avoid having issues, I'm going to put a huge pipe going into my detention. I know this is ridiculous, right? So you're going to put this pipe into your detention, and what did I say about the elevation? So if your pipe enters your detention, it cannot enter your detention below the inward of your detention. Why? Because it's not going to pipe anywhere. It's just going to stuck in the ground, right? So you need to make sure that your inward elevation, first of all, has to be inside of, you specify this as 10 feet elevation, and this is 16 feet, right? So whatever you do, you need to make sure that your pipe stays within that range for the program to understand that you are doing things, you're piping it through gravity flow into your detention basin. Okay? Otherwise, it's going to be an adverse flow going uphill. All right. So I'm going to say that the inlet inward, just make, I'm going to make things up. Let's say 12 feet. Outlet inward is 10 feet, where my bottom of my detention is. Okay, and then I'm okay with everything else. Okay, now I successfully transfer the water from my junction to my detention. Okay, any questions? So if you want to continue on, you can basically put a hypothetical node here, and then connect your detention to this node. Okay, just to see if things are working okay. Okay, you can right, but for my purpose, I don't want to. You know what? Maybe I could. Okay, so I'm again going to put a 4-inch. Oh, it knows invert 10, and then I'm going to put an invert of 8 feet. Okay, length is going to be, where's my length?
Length is above the inlet.
Where?
Physical properties, right above 10.
Go up to.
Okay, so you can prescribe the length. I'm going to do a probably 50 feet length. I forget to do this length here. So do this. Okay, so you can hit on the run just to see if you have entered in all the needed things. And if not, it's going to tell you that there is an error. So it's very user friendly. And in this case, everything works out. So no need to worry. Now, at this phase, if you want to go in and make corrections, you still can, right? And in fact, a lot of times you do need to make corrections to this point. If you look at my model, that blue dot pops up, and then the red line basically pops up, right? That basically tells me that I have, first of all, the red line has a length. That means I have pressurized flow, which is not good. And the blue area means that you have surcharge. Now, sometimes the blue dot appears on your detention basin itself, which means that you're overloading your detention basin. Okay, so I can now say that, okay, this is not cool, so I'm going to use open channel to make this and see if that's going to take care of my problem. Okay, just for the sake of having a clean model. Now everything is overflow. Okay. I have an idea. So let's cheat. Let's say I have 5 acres. Okay, and 5 acres. Just to have a clean model, I'm going to cheat a little bit. You know, what's the issue here? Maximum water depth is 13. I don't know why. Let's try outlet. I doubt it's going to this how a clean model would look like, right? So the next step. So now I have a tension here that will basically store, but it doesn't have the control of outflow that I want. That means I'm still releasing more flow than I'm allowed to, right? So what do I do? Okay? The next stage is I want to design my outlet structure. So what do you do when you design your outlet structure? Basically, you make a sketch of the different events. Right? You put it on over here, and you start putting in the type of outlet control you want. Right? So we only learn to, in this case, we only learn the sharp pressure here and orifice. So I can say that at a certain elevation, I'm going to put my orifice, and at the top, I'm going to put my heel. So you can have like an initial concept of what you want your outlet structure to look like. Okay? And then you can start also by saying that this has center line associated to it, and this has a certain elevation associated to it. So by doing this, you have a great starting point. Okay? And I'll tell you why. Because you are not going to have this nice drawing inside of SSA. The way the SSA handle it is you are going to put in each one of this as an individual thing. Okay? So let's do it. Let's do it. So I'm going to delete this link. Okay? I'm going to delete this link to create my outlet structure. So, you see this? And this button? This is an orifice. This is an orifice. This is a beer. Okay? You can also find it over here, orifice and beer, if you prefer to do it that way. Okay? So let's say I want to put in information of my first orifice for my first event. So I can click on orifice and say that I already have a design that I have on paper, and I want to follow that. So I'm going to say that from my detention basin, I'm going to go through this orifice, which I click on an empty spot, and then it's going to release the flow into this junction. Okay? So now you have this orifice that comes out that's linked to your detention basin. So click on that orifice, and now you have the option to put in the size, where your elevation of your orifice ought to be, right? And then how many of these orifices that you're going to use at the same tier, and so on and so forth. Okay? So let's say I want to put a circular orifice. Okay? Circular, you select circular, and then pipe is on the side of your detention basin box. Okay? You can put it on the bottom. Bottom means it's water is going down. Yeah. So really it should be at the top. If you want to put it at the top of the detention basin, right? That's where you say it's bottom because water is going down. But anyway, circular on the side, and then you want to put in the diameter. So I'm going to let's say 12 inch diameter, and here's the different thing that we have versus what they have. So they basically want you to specify the stress elevation instead of the center line, right? So if you know what the center line is and you know what the diameter of orifice you want, then it's not very difficult for you to figure out what the crest elevation is. It's just adding the radius. So hypothetically, this needs to be known before you actually put in that, because you need to match the elevation with the elevation of your detention inlet and the top of the detention basin, and make sure that it's between those minimum and maximum elevation that you want. Okay, so in this case, my minimum is 10, right? So my crest, since this is a 12-inch diameter thing, the minimum I can have is 11, the crest. Right? So I'm going to put it like that. Okay? you're done, it close. Okay? Now, if you want another orifice, you can do the same thing. Okay, now I want to have my crest still 12-inch, and then I want to have my crest of my orifice to be whatever, 12, right? 11, and then I know this has to be 12.5.
Yeah, what's that?
You have to have a little bit of spacing, right? So, but anyway, you get the picture. So now I have two orifices, so you can add as many orifices as you want. Now, if you desire to have the exact same orifice at the exact same elevation, then what you want to do is instead of adding like 10 different orifices, you can just add. You can just add by adding, by clicking add over here for orifice number 1. So you can specify how many barrels you want simply by doing that. Okay? Now, I'm going to put a beer here just to show you what type of information you're going to need for your beer. I still have 4 more minutes. So the crest inward elevation. So the beer is specified. This part here is the crest of the beer, right? Where you measure your age. So that needs to be below or contained within that elevation for your detention basin. So make sure you have that. So let's say my beer starts operating. 16 is the max, right? 15. I'm going to put it in 15. And then since I have 1 side, 2 side, and the 3rd side for my beer, I'm going to specify a maximum of 90. I don't know. And of course, you need to have a preliminary calculation, not messed up. And the total beer height 1 feet. Okay, this is going to be a rectangular beer. Okay, you don't need to worry about the CD being different than what we have, because the calculation is being done within, and they use a different equation. Okay, so once you are okay with that, just hit OK. Right. So now you can run this model. So have error. Oh, no error. It means everything is good. Now everything is good for your model doesn't mean that everything is good for your project, because you need to make sure you don't exceed the pre-development now because of this. So again, you need to check your results. What was the junction name? Hold on. Go back here. Okay, junction 4. So now I can plot. Now I can plot my results for the junctions. Where's my junction? That's weird. Let me close this and rerun this again. It should appear there. Okay? For the junctions, because I don't care about the each individual orifice. I want to know what the collective effect is. So I'm going to be plotting my outflow for my junction. Ah, there we go. So if you click on this, right, you can actually list out the pre-development flow. You have post-development, and then you have post after you install your detention basin. Now, what you want to see really is your post after you install your detention basin doesn't exceed your pre-development. That's the main goal. Okay. So you can output